So in the last session, we have just introduced you about the MATLAB and Simulink, and that also Pratyush show you that how you can just quickly start with the Simulink. Okay. So further, we are just going to discuss more feature on the Simulink. Any specific question in chat? Okay, Kanchan also just reply that 18%. So it's better. Just you can just move. So in the last session, you just saw some simple example that how you can just start modeling your systems. So Simulink also could be used in for different type of applications. If you want to work with some complex system, maybe there are some examples like we can use it for wireless communications, motor and control design, control system applications area, robotics, or we have the library is available that we can just use for IoT applications also. So as you know, if you're going to model your system, we have actually basically two approach here. First one is your first principle approach, or it is called the physics-based approach, or it is termed as the mechanical modeling. And what is the second approach? We have this data-driven method, like using the AI. Suppose you have some data, we can build some type of models based on our data. So we will discuss this approach in the upcoming sessions. And today we will concentrate on this first principle or physics-based method of your modeling method. So there are, as you are aware that we have the Simulink, but on the Simulink library, on the top of the Simulink library, we have Simscape product of family is available, which could be used for physical modeling. So basically, what is physical modeling? If we just visit into our Simulink library, so there is some limited component is available. But for a if we talk about as a electrical engineer and you want to design simulate some type of power systems or any type of your electrical system, so there is no component is available within the Simulink library, which is limited. But what we can do that if you are going to design some complex system, like for example, you want to analyze your some smart grid electric vehicle, you want to work on some type of some systems like your different type of converters or electric motors, bridge, different type of or different type of electrical or multi-domain system. So you require some type of component, ready-made component. So which like resistor or capacitor or different type of motors. So how we can just quickly move to the Simscape. So we will just discuss that what is the difference in basically in mathematical modeling and what is your actual physical modeling here. First, we want to just discuss you one user story that how the industry also using MATLAB and Simulink for their applications. So I have just taken this user story from the ether energy. I hope that you are aware about this electric scooty. Okay, so this is India based. We can say the startup company. So this ether energy developed this electric scooty using the MATLAB and Simulink. Okay, so here I've just shared the link, or you can just go onto the some Google and you can just search out that how the ether energy use MATLAB and Simulink to develop this type of scooty. So what are the challenge with the company that design and produce India's first intelligent electric scooter? Okay, then what the solution they get? They use basically model based design to simulate and optimize the scooter, design and to generate the production code for its control software. So as you are aware that in the MATLAB and Simulink, from the MATLAB programming as well from the Simulink block diagram or models, we can directly generate the code. So we have the code generation product family is available if you want to deploy your Simulink model onto some specific hardware. So depending on your hardware, like if you want to deploy on some type of embedded controller or some type of FPGA devices, so here code generation is possible here. So using the MATLAB and Simulink, the result, what they get, design an alternative, evaluate in weeks, not months. So basically this reduce the development time, testing time reduced by 50%, and field issue rapidly resolved. Field issue means that they already analyze or simulate this system into Simulink environment. They provide the different type of thermal conditions, or and apart from this, they also develop some type of charging stations with this also. Okay. So this is one just example that how the industry, and I have taken this from the Indian startup for this one. So apart from that, if you just visit on the MathWorks page, you can find out a lot of story that for different type of applications, how the industry also using this type of tool apart from the education. Okay. Then just why we are just using this Simscape or Simulink environment. Like you have some, for example, we have just taken one example of your RLC circuit here, okay, or this is RC circuit, okay. So how you can analyze any particular electrical system or multi-domain systems. So here we have this Simulink or Simulink product family is available with us. Or what we can do, we can convert our electrical algorithm or theory into different type of applications. If we talk about some like grid, this is your grid, or some power generation, solar power generation, and this is your you can we have some special type of toolbox if you want to work on some type of vehicle simulations. So Simulink environment provide you the complete solution that we can just convert that any particular physical system into Simulink environment. Okay, so we can analyze, simulate different type of multi-domain. It could be your electrical system within the Simulink environment. So on the top of the Simulink, we have this Simscape product family. Okay, so Simscape basically have 6 product families available. So this is only Simscape product is available. So within the Simscape product, we have library is available for different domains, like from electrical component also available, mechanical, magnetic, if you want to include some thermal effect into your system. Then we have the isothermal or two-phase gas. So different type of library is available if you want to design, simulate some physical system within this Simscape product family. But there is limited we can say the component are available. If you want to work some advanced electrical system, so we have this Simscape electrical. So few years back, actually there are 2 different toolbox are in the MATLAB. One is sim power system, and sim power system generally used by the electrical engineer, and for electronics engineer there are a separate toolbox. This is called the sim electronics. But as you know, if you are working on some type of electrical system, so combinedly we have some component from the electrical background or electronics background. If you want to control your electrical system, so generally we include some power electronics component for this one. So MathWorks did that. They combine both the toolboxes like sim electronics and sim power system in a single toolbox. This is called Simscape electrical. Okay, so now we have combinedly libraries available for electrical or electronics. Obviously we have some mechatronics or other libraries. So if you want to just build your electrical system, and you can find out some more advanced component in this Simscape electrical library. Further, we have this Simscape driveline. So if you want to just design, simulate some type of rotational and translational mechanical system, maybe if you want to work on some type of EV vehicle, so it has or some type of gearbox or something like in different type of rotational or translational mechanical system are available within this library. Okay. Then we have, because a lot of work is going on electric vehicle today. So in the last year, MathWorks created or this is separate toolbox and Simscape battery. So using this Simscape battery, you can just design and simulate your battery and battery management systems. Then we have this Simscape fluids. So to design your engineering system, maybe you want to simulate some type of flowing element, maybe in the some industry, some gas or something is flowing. So if you want to design, simulate some type of flowing systems, so we have the libraries available within the Simscape fluid here. Further, this is Simscape multi-body. So we can just model and simulate multi-body mechanical system. For example, suppose you want to just design, simulate some working function of JCB. So how you can just design this type of or some type of robots, that how the robot will work, how the arm will be turned. So we can just apply some type of forces and we can just analyze the system, that if we apply some particular forces onto my JCB or any particular machine, that how it will work in the real world. So using these product of family, we can just build some complete physical systems. So the library are available for all domain here. So further, we will discuss that what are the toolboxes available with the control system toolbox if you want to include. So it's better that let me just switch to the MATLAB. And we are aware that how we can just launch this library. So we have this Simulink, and if you want to just launch the library, so how we can just launch the library, we can just open this blank model, and from that model we can just launch the library. So in the last session we have only, so within this there is
मीटिंग ज्वाइन कर लो, पैसे तो नहीं जरूरत नहीं।
hello
पहुंच गए हमसे नहीं क्या लगे, बस फिर दूसरे से भी बाद में हम लोग थक गए मीटिंग करने के बाद, हम लोग चले गए तो वहाँ लेकिन
Monica, can you control or mute the participants? Okay, thank you. So in the Simulink, we have some limited library that you have just if you want to design, simulate some system using the some mathematical approach, whatever you have seen in the last session. But here we have this Simscape product family is available here. So within the Simscape product family, as I just told you, that we have 6 toolbox options are available. Okay, so like we have this Simscape battery, Simscape driveline, Simscape electrical, fluid, multi-body. Okay, and this is the foundation library. So this foundation library you will get if you just install only the Simscape product. So under the Simscape also you will get the library of all domain, but these are the some limited component like resistor, capacitor. But if you want to get some advanced component within your domain, so suppose from your electrical background and you want some advanced components, so within this Simscape electrical, we have some advanced component which are the like different type of connectors are available here, like bus bar, different type of, if you just go through to like controlling your we have the BLDC control, different type of converter options are available, If you were talk about the electromechanical system, so ICs, brushless motor, different type of ready-made motors are available. Okay, so there are two type of approach to model your system. Like we have the mathematical modeling approach. Okay, so just we will take some simple example and we will discuss that what is the basically mathematical approach of designing your system and what is basically physical modeling of your system. So for example, let me just open one example, and suppose as a electrical engineer, just I take one example of series RLC circuit. So if I say you this is a model of series RLC circuit. Okay, just think that this is a I say that this is a model of series RLC circuit. So how it is possible within the Simulink? So suppose we have the series RLC circuit. So then you apply some KVL, KCL, then you find out some apply some Laplace transform or other method, and you get this type of equation from series RLC circuit. So what is this equation is? L d dt q square by dt square plus R dq by dt, and q is your charge, R is resistance, L your inductance, and this is your q 1 by c into q equal to input voltage. So once you get any mathematical equation or ODE from any system, for example, if you solve only RC circuit, so just solve that RC circuit, you will get a mathematical equation. If you want to if you want to design your motor, electric motor into Simulink environment, so electric motor has two domain. One is your electrical domain, and mechanical part also has the electrical motor. So you have to apply electrical you will get some electrical OD equation as well as the mechanical part OD equations. So maybe you will get 4 or 5 equation from your motors if you want to convert your electrical motor into some mathematical form. So how you can implement any mathematical equations to some type of model. So what is the rule? If you get some OD here, so it is a 2 degree here. Okay, so always remember that just keep your left highest order term into left hand side, and rest just you can just bring into the right hand side. So if I just shuffle it, and what I will get V in minus 1 by CQ minus RQ dot, and in the left hand side I have only Q double dot and 1 by whole here. Okay, so how I can just start to building my this series RLC circuit using the Simulink block diagram. So if you don't install the Simscape product family, so still you can build your system into Simulink. Okay, so how you will, so in the last session you have also seen that if we integrate acceleration, so we will get velocity, then integrate, so we will get the displacement. So what I can do, I can just insert a integrator here. So this is my integrator, and just let me just assume, I just assume this one, that I double click here, and I assume here this is my Q dot dot. Just I have just assumed here that this is my Q dot dot, so second degree of my charge. And if I integrate, what I will get here, Q dash or dq by dt. Okay, then again I will integrate, then I will get the only charge Q only. So like this, what I can do, I can just start to building my circuit from here. So I can assume here Q dot dot. So this is my Q dot dot. I assume here Q dot dot, that I can apply here two integrator. So I will get Q and Q dot dot. But what is the best part of MATLAB? I have also one component within the Simulink. This is called integrator of second order. So instead of just apply to indicator, I can also insert this single indicator, second order. So it will provide me both option, Q as well as Q dot. Okay. So this is a component name. If you want to see that what is the component name, second order integrator, you can find out this into the Simulink library. So I just assume here that this is my Q dot dot, and I will get here Q and Q dot here. So what is the multiplication within this Q? 1 by C. So I can just insert here 1 gain, and this is my 1 by C. Okay. Then what is the multiplication in Q dot? I can consider it, this is my resistance, and I can fill the value of resistance into this workspace, base workspace here. Okay. So like this, now I have what is my equation? V in minus 1 by CQ minus RQ and whole by L. So now V in my positive, so I can add a sum block here. Okay, sum block. So by default, if you add some block here, so it will give you only by default as a two sum or plus sign. But what you can do, you can just double click, and according to your requirement, you can just edit it like some minus, or if you require 3 plus, or you can also change the shape of this one. So if you don't want some round shapes, you can just convert into your rectangular shape. Okay. So in this way, I have just inserted a sum block here, but I have two terms as a negative, and one is V in is my positive, and V in is my voltage. So I can just say it, I can give the value of 24 volt or 12 volt, whatever I want to say. So I can just take a constant block here, and this is my negative, this is also a subtraction, and this is plus 1. So overall, what is this? I have converted my mathematical equation into Simulink model. Okay, so this whole system is representing your series RLC circuit. Okay, series RLC circuit. So this is a simple example that to understand that what is basically mathematical modeling. If you have some mathematical equations from your systems, and within the Simulink environment, you can convert that particular mathematical equation into your systems. Okay, so this diagram is representing your series RLC circuit. But what will happen if you want to work on some more complex systems? For example, if we talk about the DC motor, we will take the example later on. So DC motor has two components, mechanical and electrical. Then if you are going to derive the equation from that, so what you will get? You will get 4 to 5 equations for electrical as well as your mechanical part. Then you have to assemble like this, all the things. So your electric motor will be very complex, which has lot of blocks available. But what is the solution? That so we have this Simscape product family is available. So if you again just visit here in the Simscape product family, so we have different type of ready-made component or physical component or real world component are available. Because if we study our RLC circuit or motor in a theory part, so we have a special symbol of resistance or inductance or battery. So this actually library will help out you to quickly build your physical systems. Okay, so within this library, we have this electrical part, and if you go to the electrical element, there are resistance, inductance, or different type of your electrical component are given here. So using the Simscape product family, we can quickly build our physical system or multi-domain system by using the library. These are my electrical sensors are available. If you want to measure some type of current, like using this current sensor like ammeter, using the ammeter, it will work as a ammeter. As you are aware that if you want to measure some type of current, so we generally put ammeter in series, and this is my voltmeter, or this is called the voltage sensor. So if you want to just measure voltage at any particular from any particular component. So you have to put this voltage sensor in the parallel of that component. So there are two type of components are available, or two type of components are available. So depending on your domain, suppose you are working, so this is called my across. Across means you are going to connect across the, and this is your throughput component. So across component and throughput component. So if you are going to just want to work on any other domain, so there are different type of, so suppose for flowing component, if you are working in the thermal domain, so there are different type of across and your throughput component or approach are available for this one. So let us say that I want to design the same circuit but using the Simscape product family. So what you can do, you can open a blank model. So that I can just show you that quickly, that how we can design any particular circuit quickly into my Simulink environment using this one. So what I can do, I can open a new model window, the same model window. This is my new model window. I can open like here. Okay, I need the component. So what I can do, I can take the component from the library. But once if you go to the your Simulink library or any of the library, so if you just remember the name, like you require the register, so you can type here register, and it is showing me electrical element. So you can take the register from here. Okay, but this register comes under your Simscape electrical library. Okay, so this is my register. Then what I can do, I can also connect here some inductor. So I can type here inductor, and from the same library, I can also take a inductor. Now, what I can do, I can just insert my capacitor. Okay, so this is my capacitor. And so if you want to rotate any component, so what you can do, you can right click on any component. So you will see different options about the component. Okay, so different options like masking or this one. But there is a if you want to rotate your component, so if you just go to the format, so there are different type of show block name, rotate, or this one flip block. But if you want to rotate using the some command approach, so you can just type here Control R. So using the Control R, I can rotate my component. Okay. So for series RLC circuit, I require just some voltage source. So this is my DC voltage source. Suppose I just take this is my DC voltage source. Again, I have just completed my components. So what I can do, I just can connect these component. So this is my, like I'm just modeling my system. Like I just so this is my series RLC circuit. Okay. So if you just going to simulate it, so it will not display anything. Okay. So because I have to just connect the scope here. Okay. So now just see the difference. What is the difference in this approach and previous approach? In previous approach, we are just going for mathematical modeling of system. Okay, but this is a physical modeling of your system, because you are going to implement your real world component directly from the library. So just see the difference, what is physical modeling and what is mathematical modeling. If you have the mathematical equation of your system, you can choose the component, you can connect them, that component, we can say mathematically, but this is a actual physical modeling of your system here. Okay, so now if you want to just analyze something from this circuit, suppose you want to measure some voltage across capacitor. Okay, so what we have under this library, we have the voltmeter. Okay, or this is voltage sensor. So what I can do, I can just search the voltage sensor from this library, And what I can do, I can just connect this voltage sensor. Okay. So by pressing the space bar, what you can do, you can just place your whole circuit in the full screen mode. Okay. So this basically this voltage sensor has 3 terminal here. One is positive, one is negative, and this is output. Okay. So what you can do, you can also rotate it like this. So what I can do, I can connect this positive to here, and this is my negative, and I can connect this negative terminal here. Now this is for draw your output. Okay, so I can connect here some scope. Okay, this is my scope, and let me just try to connect it, and it will not connect. Okay, what is the reason that it is not connecting? Because this component is a part of Simulink library. Simulink library. So don't confuse Simulink. We are still working in Simulink environment. Simulink is a whole environment, but Simulink also has its limited library, and this is the component from the Simscape library. So that's the reason that we cannot directly connect these components, because these components are made up of a second method, another method, and these library is, if just click on this register, okay, and if we go to the here description, so it is the source code. So basically, Simscape library is made up of or created with some type of special language. This is called the Simscape language. So Simscape is a language by which these all components are created. And if you want to learn more on this language, so this is the syntax for this one. Suppose if I type here component, what is my component name? Register. And in which library I'm going to include? Foundation library, electrical branch library. And you can just read, this is the command, all the things. Further, what are the parameter you are going to declare? Like this, it will show R equal to 1. By default, it will show the 1 ohm value to me. And these are the intermediate things I can insert. So this language is, this is called the Simscape language. Okay. So .ssc. So if you want to learn this language also, you using this one, these all the components are editable. So we can just also create this type of component. So you can also find out the source code of each component. And this Simulink library was created with a different method. Maybe these are created some Visual Basic language or something. Okay. So directly we cannot connect Simscape component and Simulink component. Directly we cannot connect. So we require some type of converter to connect these components. So if you just visit in the Simscape library, so within this Simscape library, we have this utility libraries available. Okay. So within this utility library, we have some component which could be used for utilities. Like we have this PS Simulink converter. That means physical to Simulink converter. That means it will help out that if you want to connect your physical component to the Simulink component. So what I can do, I can just insert this PS2 Simulink converter here. And now what I can do, I can just feed here this one. And now it is connected. So this is my PS2 Simulink converter. But in case, suppose you don't want to provide the your voltage from the Simscape component, and you want to bring some input into your physical model from your Simulink environment. So what you can do, we have another component. This is called Simulink to PS converter. So vice versa is possible. You can export your signal from physical system to Simulink component, or vice versa also possible here. Okay. Okay, now my circuit is ready. Okay, so can somebody tell me that is it okay? Is it okay or anything else as an electrical engineer? Just write in the chat. Is it proper or something remaining? Any answer? No idea. Yes or no? Just you can say, I don't have idea, no idea, or say it is completed or no. So as the electrical engineer, just first things you have just learned that if you want to measure something like voltage, so you have to measure your voltage with some reference. Okay. So here you are just applying here voltmeter, but here we can just put here, suppose this is my 5 volt or something, 1 volt, or I can just take it, let's suppose this is my 12 volt. So 12 volt, but for volt reference, that means you have to just insert some reference point within this one. So you will always measure your physical quantity with respect to. So we have the electrical reference. So this is my electrical reference signal. So based on this one, I just will measure my voltage here. Okay. So now what you can do, you can just put your DC voltage source, like if you want to use the 12 volt or something, this one, and this is your resistor. You can just take it by default as a 1 ohm. So from here you can change the value. You can take it in the ohm or kilo ohm, whatever you want to. And there is another difference. If you only put in the constant, if you put here only constant and you feed here 24. So in Simulink component, you are just feeding the value. Suppose you want to add two values, two constant block, and you put here 10 plus 5. So what is meaning by 10 plus 5? 10 plus 5 may be anything. It is not denoting some physical quantity. So 10 plus 5 means it will give you 15 result, but 15 what? 15 may be rupees, 15 may be your voltage, whatever the quantity you want to consider, it will give you the answer. Okay. But here we have proper units. Okay. So in this, we have the proper unit, like we have just put the we can put everything like in the description or this one. So here we can put this is 1 ohm or 1 kilo ohm. Okay. So like if you are just going to run this one, that I want to simulate this. Again, it will give me some warning or error. So what is this error basically? Just remember one thing, once you are going to just design your physical system using the Simscape product family, just remember another component to insert. This is solver configuration. Okay, solver configuration. You have to just insert the solver configuration always within your circuit, within your system. Okay, so this solver configuration block you can connect anywhere in the corner something. Okay, so what is meaning by this solver configuration? This is basically just provide the setting to solve these equations. Okay, so this is the description. Define solver setting to use for simulation. So always remember this component you will add at any corner of your circuit, And this is another extra component that if you want to carry your physical signal into Simulink, so here we have just added two extra component. Okay, now if you just go and simulate it, it will, no error will come, and you can just so now it is compiling, and you can just watch out your result. Okay, so this just I have just explained you that it will be easy to understand to build your own circuit. Maybe if you are working on some complex circuit or project, so this will be the method that you always follow this rule, that how you are going to connect the component, what are the basic component you require for that. And now I have two already blocks here available. So let me just open my MATLAB. Let me just open here the component and ready-made. Let me just open this RLC. It is already open, and this is my RLC Simscape. So are you getting that what is the difference in mathematical modeling, and how this Simscape is useful for me, for your yeah. So now, okay, so we will always work combinedly. Sometimes you require the component from the Simulink, and sometimes obviously you are going to use this library. Okay, so still we are working in Simulink. Simulink is whole environment. Okay, and Simulink also has a limited library, which may not be sufficient to building your own physical or electrical system or multi-domain system. So we require the Simscape product family, and within the Simscape we have 6 different library or toolboxes we have. Okay, so mainly you need to just concentrate on this one. Okay, any question so far? Are you getting this? If I just simulate both circuit, like from the Simulink or Simscape, so I will get the same result. So let me just simulate this one. This is RLC circuit, and I have just designed this circuit using. So this is showing me the, and if I just run another, maybe I have to open this one. This one, okay, and let me just run this one. So both circuit are same. One is made up of using the with the help of Simscape, and second one, this is, yeah. Any question? Are you getting this? Okay, I think you are. What is the function of solver? That is a good question. Okay, just try to understand that here in the Simulink. Okay, I think just take one example that if any type of circuit or any type of system we are building in Simulink. Okay, so we are basically connecting. What we are doing, we are basically connecting the blocks mathematically. Okay, and what is basically blocks? How we are connecting? Because we have the ODE, ordinary differential equations. mathematically we have. So in mathematics, you just also learn the solver, different type of solvers like OD45. This is Range Kutta method. Range Kutta method, it is very famous. Okay, so to solve your OD, we have different type of solver. Okay, so if you just OD23, OD45, so these are the different type of method are available to solve these ODE. So basically, once we connect these Simulink blocks, so if we run our circuit, so in the background, these blocks are solved by some type of solvers. Okay, solver means like OD45 or different type of solver. So for example, if you are working as an electrical engineer and you require some type of different solver. Okay, if some mechanical engineer is working, maybe they have some different block diagram. So for that, they require some different solver. Okay, so within the Simulink, we don't need to insert any solver block separately, because if we talk about the Simulink, here we have the modeling. In the modeling setting, and within this modeling setting, we have this model settings options is available. Okay, so by default, the solver work from here. These are the solvers are available like OD45 or something. Okay, these are the different type of solvers are available. Okay, but if you are working on this type of systems, like you take the component from the Simscape library, so we require some type of special type of solver setting. Okay, so what solver setting? So we doesn't mean that what we have to setting the things, only this solver block take care. Okay, we have to just put this one, you take care of my settings. Okay, so this configuration solver just solve these Simscape blocks in the background. Okay, because these blocks are basically are some mathematical equations. Okay, getting? Okay. Now we move to the more example on if we talk about the more complex system. If you go to the motors, okay, so motor also what you can do, you can design your motor into your MATLAB environment also, as well as Simulink environment also. So let me just open a how you can represent your motor into MATLAB environment. So generally, let me just open this DC motor model, and you study this type of equation. So this is representing your motor. Further, if you want to define some parameters into MATLAB environment, like in the live script, okay, so you can define this inertia, or this is viscous friction. So if you want to design, simulate your physical system within the MATLAB environment, and as you know, if you want to change the parameters frequently, if you want to simulate your systems, so it is a better environment. Simulink is a better environment. If you can just single click and do if your simulation is going on running on. Okay, so during the what is basically a difference in programming language in programming language and your simulation environment. So just understand one difference, that if your program is running, or maybe your C program or this, during the running position, if your program is running or compiling, so during the running time, you cannot change your parameter generally in programming language. But within the Simulink, if your system if you simulate some type of system, and during the simulation you can change the parameter, okay, so it will affect your simulation. So Simulink is a better environment if you just going to analyze or design your some dynamic systems. Okay. So this is that if you want to control here, so everything you can also just go here for controlling purpose. Suppose you want to design and simulate your or control your systems. So for controlling purpose, so I think some student from the second year, so maybe you have not just study the control system, but just little bit idea I will just give you. One approach is that you can just represent your system into some type of this mathematical equation. And second, generally in the control system, you can represent your system into different type of we can say format, like transfer function form is available, zero pole gain, state space, so FRD frequency representation. There are different type of form you can just represent your system. For example, within if I just let me just open the Simulink library, and here we have this Simulink library. Okay. And in this continuous category, if you just visit into this continuous category here, so we have these blocks are available. So let me just show you this transfer function block and state space block. Let me just insert this one. So how you will get this transfer function form? Just apply some KVL, KCL, and there is some one Laplace transform is there. If you just apply the Laplace transform, so you will get this transfer function form from your system. So if you know the transfer function form of your system, so what you can do, you can just insert your transfer function. So basically in this form you have some numerator and some denominator. Okay, so let me just first let me just show you that how you can just enter your numerator and denominator parameter into Simulink environment. Chat. So let me just, if you want to declare your transfer function form within the MATLAB. So what we have, for example, we have we have a system of 1 by s plus 10. Okay, this is my system. So in numerator, I have actually in numerator 1. So I can define n or num, anything I can. So in the numerator, I have 1. But in denominator, what I have s plus 10. So I will not directly type here s plus 10. I will type here coefficient of each s or s square. So what I have here, what is the coefficient of s here is 1. And what is my constant? 10. So if you want to type two values, so you have to enter like 110. So this is my numerator coefficient and this is my denominator coefficient. Okay. So once you declare your numerator coefficient and denominator coefficient in the form of coefficient, okay. So what you can do if you want to represent your system into transfer function form. So we have this TF command means we are going to represent our system into this form. So you can pass your n comma d numerator coefficient and denominator coefficient, and you can just save into a suppose system. So in this way, what I can do, I can just define my transfer function form. So if you have transfer function form and you want to represent that particular system into this one, so basically it is a continuous. Maybe you have the discrete type of. So what you can do, you can put here something like, okay. So if you have the discrete system, you can put third argument as your sample time. So using the same command or function, I can just declare my transfer function form like this one. And what is another form? This is a ZPK, zero pole gain. Okay, so zero pole gain, what I can put? I can put what is basically zeros. Zeros is numerator. If you put your numerator whole term equal to 0, then you will find some roots. So these are the zeros and these are my poles. Okay, so if you put your denominator, you will get the poles. So if I talk about the poles of this one, so what I can do, I can type here pole, or maybe it's poles. Let me just check out. So if you want to find out the pole into here this one, so I have only one pole. This is -10. Okay, so zeros pole. So using the zero command, I can find the zeros from any system or poles. So if you know the zeros and pole only, so how you can just represent your system using the ZPK form. So you can put here, suppose I have 10 is 0, or I have 2 0 here. Suppose I have 2 0 2 and 3, and I have these pole, I have these poles. Sorry, this will be as comma. It will accept 3 arguments. Suppose 2 3 5, I have these poles, or I can take also minus, maybe. Okay, plus 2. So maybe system is stable, and this is my gain. So like this, if I know the zeros, pole and gain, so I can represent my system like this one. And third one is my state space. So if I want to convert into a state space, okay, so if you know the A, B, comma, C and D, so these are the four we can say the matrix. So if you are going to study your state space, so you will get some special type of equations. So if you know the matrix of A, B, C and D, okay, and you have the state space form and you want to represent that state space form into MATLAB environment, so what you can do, you can pass the A matrix, B matrix, C matrix, and it will generate the your state space form. But still, suppose you want to convert this transfer function form. System is my transfer function form, and I want to convert this into state space. So it's also possible that if I have one type of form of my system, I can convert to other type of forms. So this is the part of your control system, that how you are going to just declare your system into MATLAB. Then in the control system, you're going to study a different type of special plot. Suppose if you want to just put here a step plot of your system. So what you can do, you can find the step response, that how your system is working like this. Okay. So step response, sometimes you have to just study the body plot, but within the MATLAB, what you can do, by just using the simple command, you can put here, maybe my system is not correct, so it will show you the body plot of your system, board plot. Then you will also study the Nyquist plot. So it will take some time if you're going to solve theoretically Nyquist plot or body plot, because you have to do a lot of this. So, but here in the MATLAB, there are inbuilt functions are available to finding your step response or body plot, Nyquist, different type of pole zeros. So it will provide you the Nyquist plot of this one. Okay, so these are the different type of approaches are available, that how you are going to design and simulate your system. Okay. Further, let me just move to the further into this Simulink environment, and if you let me just open this same motor into Simulink. So this is your motor diagram or motor model. But for what approach? Which approach is used to build this motor? Just write in the chat. Which approach is used to build this motor? This is representing your DC motor within the Simulink environment. Okay, the Anirudh mathematical modeling approach. Okay, so if you know these equations, So you can convert your motor. This is representing your DC motor here, which has two parts. I have this mechanical part equation, and this is my electrical part equation. So I can just connect the things here like this, and I can just, okay. But within the Simscape, I have the ready-made motor is available, DC motor, different type of uh, advanced component is available. Okay, so directly I can just go into the library and I can just insert this one. So for example, let me just open here another example, and by using this we will also see that how you can just control that particular model. So we are going to just utilize the control part also. So let me just open this. Maybe it's better that I can open setting. I have one type of dual example. Okay, I can just include this example. Okay, just wait. I need to just insert from another folder. Or maybe I have this. Dual, actually I have one. Okay. So let me just open this motor is designed using the Simscape approach. So now I think I hope you are getting the thing that how you can easily design your motor or other system with the help of your Simscape library. So let me just open it. So this is my DC motor. Okay, so are you getting it? That this is my DC motor. This is your motor RPM, torque. So just understand one thing here. Actually, if you are using component from different library, like here we have the component of two domain, blue color is representing your electrical domain component, and green is representing your mechanical domain component. Okay, so to differentiate different type of just domain, so method just uses the different color. So blue part is belong to the electrical component or electronics, or and this is your, so this one. So like this, you can just apply your some type of voltage or motor, and you can just notice the things. Okay, so this is that how you can just model your any type of system, like your, we have just started with the series RLC circuit to understand the mathematical modeling and your physical modeling. What are the tools we have used for this one, and FX also is given. Okay, and if there is some requirement of this one, so we are going to connect this one. Sensing means maybe it is written only sensing, but maybe if you are just double click on this one, it is representing like this. Okay, so here P to S converter. So for this what is happening here? What is happening here within this? If I just double click here, so again another circuit is open. So what is this basically? What is this? What is meaning this one? So this is called subsystem. So maybe if you are going to design your or model your complex system for any complex system, and your circuit have lot of component. Okay, so how you can just reduce that particular logic in a single block? This is called subsystem. For example, let me just take you one example, and it's better that I can open a, what is basically how you can create the subsystem. For example, I create here like some sine wave. Okay, so this is my, this is my sine wave. Okay, and what I do here, I just pass here integrator, and I pass here some integrator. This sine wave I pass to the integrator. But after integrator, what I'm doing, I am also want to amplify this. So what I can do, I can just insert the some gain. So after integration, I want to amplify also. Okay, and then I connect here scope. So this is basically my representing this. Okay, so what is the logic of these two components? Suppose I want to amplify 5 times. Okay, gain. So what is the component of these two? These are integrated and amplifying. So what I can do, I can convert these two blocks, because I am applying here in a, if you go to the format or here create subsystem. So what I can do, I can click, I can select both middle block, and I can convert into subsystem here. So sorry, I think all blocks are selected. Okay, so what you can do, you can just double. Okay, only I need to select only 2 blocks, then right click, and you can create a subsystem. So in between, what you have just done, you have created a subsystem. Okay, so in this way we can create a subsystem. So subsystem to reduce our complexity, but within your subsystem you have applied some type of logic. So it is happening here also, like if you find this type of blocks, and you can write anything, you can write by this integrate and amplify. So you can just give the logic name here like amplify and integrate. So this is your subsystem. Once if you are going to just work on some complex system, and I want to discuss one thing. Sometimes no need to connect this one. Okay, always, because if you're going to work on some complex system, so maybe there are you want to measure 30 things, you want to measure signal on 30 places. So if you are going to insert 30 scopes into a single system, so your in your system there will be always scope. Okay, so what you can do, you can terminate your output using a out block. I have just terminate. I don't want to insert the scope. But what you can do, you can just right click here, and what you can do, you can just insert a viewer like scope. So it will be some small window will become here. Okay, this is your scope. Here is scope. If you run this one, and if you want to analyze something, you can just click on and you can analyze. Okay, so instead of inserting separate scope, you can just terminate. You have to just need to terminate your output, and you can insert here you can insert number of scopes. So your diagram or your modeling will be look like better. Okay, there is another approach also available, that how you can just carry your signal onto the scope also. So we will discuss in some sim power part. Okay, so this is that how we can just design your system into this one. Now further, there is a, if we talk about the, if we let me just move to the here within this app section also, and we study the control system. So here we have the control system design and so in the last session we have seen that what is the function of curve fitter, what different type of apps. So the apps are available within the different toolboxes. So what is the use of these apps, that we can solve our problem related to that particular toolbox or particular domain without writing much code interactively. So here are, as you know, in the control system domain also, maybe some advanced toolbox are also available, some system identification. Suppose you have some data, only raw data, and you want to identify your system. So there is a toolbox of system identification. Neurofuzzy logic. So there is a separate controller. This is called which controller works on the fuzzy logics. Okay, so that particular controller on the fuzzy logics, and you can just use that particular fuzzy logic on your conventional controller, which is your PID controller. So using the PID, okay, using the PID controller, or you can tune your controller to control your systems. Okay, graphically method is available here using this one. Okay, then control system designer also available here. So you can just design single input, single output controller. So there are different type of apps are available. So using this one, you can design your so if you are going to launch this app, so if you are not aware about any app, so what you can do, you can launch any app, just go to the help, and step by step it will teach you with some example that how you can just utilize that particular app for your special application. So using this one, what we can do, we can just control system designer. Okay, so using this one, you can, what you can do, you can import your session. We can just tuning method, different type of tuning methods are available. So it could be body editor, close editor. So this is the part of your control system. And graphically what you can do, you can just design your CISO system using this one. Okay, so different type of approach, different type of plots you can also see the using this one. Further, for PID controller, so to tuning your PID controller within the MATLAB environment also, we have the options are available. So we have this command, PID command, and which is the part of your control system toolbox. If you want to learn more about this approach, so what you can do, you can open the document of any command. So there is PID command is available, and using that particular command also, what you can do, you can tune your system. So this is my system in ZPK form, and using the PID tune or PID command, you can pass. So PID, actually PID controller is made up of the P part, your proportional part, integrator and differentiator part. So we have to pass the coefficient of KP, KI, KD, and this is your transfer function to which, so it will accept. Sometime you can design only proportional controller combination of, or you can also pass on the PI controller, depending on your systems. Using the same command, we can design our different type of controller using the command based approach. So command already given, but to save your time or interactively, if you want to work using this PID controller also, what we can do. So for example, suppose I want to just take this system. Okay, I just only take this system as a system and let me evaluate this system. So system is in my workspace. Okay, now what I want to do, I want to just tune this one using the PID tuner. So this is my PID tuner app. So let me just show the step response of this system. So let me just, this is my step response. So because I have applied as a step response within this one, so it should go like this one, but it is going very slowly here. Okay? So it is very slowly. So what I need to do, that I can design the PID tuner, or I need to tune this one. Okay, so there are multiple approach using the PID command. I can just tune this one using the this control PID tuner. So I can just use this PID tuner app. So there are mainly two toolboxes related to control here. Control system toolbox. Okay, control system toolbox. If you want to work with control system within your Simulink environment, within your MATLAB environment, so control system toolbox is sufficient. But if you want to apply your control algorithm within the Simulink environment, so there is a separate toolbox which is called the Simulink control design. So using the Simulink control design, what you can do, you can just insert your import plant here. Okay, work is from the workspace. So I have this one and I can import this one. So now it is showing me the by default step response. So you can also add different type of plots here. Okay. Further, I have this tuning method, like this is my, I can just, you're showing that my system is slow here or fast here. So I can just adjust this one. Okay. Then I can just drag drop this to make my system robust. So just you have to just drag drop options. Maybe my system, it is not showing, like maybe system I not this one, but I can just adjust these two slider. Once your system is following this one, so you can just show the updated value of your KYP, and you have the performance and robustness like this, that what is your target, like what should be the rise time of your system, settling time, overshoot, gain margin, phase margin. So whatever your objective to achieve for PID tuning, you can just get these detail from here. And once you get, you can just finally you can export your controller to the workspace, so that you can just utilize this controller through other applications also. So apart from this app, what we can do, we can also just use this PID tuning for controlling my plant within this one. So let me just show you that what is actually happening here. So I can also represent my so this control system modeling with model object. So suppose this is your plant GS. Okay, so GS is your plant, and before the plant you always just design your controller here. Maybe your this is your feedback or some type of your pre filter you can apply. See, so there are approaches available that you can just represent your system in the MATLAB and using the command based approach. So this also available that if you want to solve your feedback system, so there are inbuilt command are available that to convert your system into transfer function form. Then if you have some type of feedback, so it will automatically solve your system using the feedback command. Then you can multiply or you can just go for the different type of plotting options are available. Then we talk about that if we design and simulate any particular system into Simulink environment and you want to control your plant maybe in this section we are going to take example from this one. Let me open this another example, and this is a motor variants. Okay, motor variant means that I'm just going to show you again that how you can design your system maybe from both approaches. Maybe it is not parameter is not there. So no problem. What we can do, we can just take one example. Maybe suppose you have some type of system with you. Okay. Now what you can do, you can just let me just if we design any plant. So right now we can just take an example of this from here and let me open a new blank model. Okay. So maybe I'm just taking this transfer function here right now. So for example, in place of this, you have designed your motor, okay, and you have converted this into single system. So what you can do, you can just insert a PID controller before your plant. Okay, so you will find out this block PID controller within the Simulink environment also. Okay, but in the behind, basically Simulink control design toolbox is working here. So what you can do, you can put your controller before your plant. Okay. Now, if you want to just measure some output, scope or something, so we can just put here the scope, and let me just you take some step response. Okay, so here what I can do, I can just step response, and you want to take some feedback loop also, open loop and closed loop system. Okay, so there are two type of systems. So I can just what I can do, this is some block I can insert here, and this is my maybe unity feedback or I can just put here the negative because it is more. Okay. So by default, this is my plant. I can take it as a 1 by, or I can say this is 10. Okay. So once you directly put, just run it. So it will show you like this one. Okay. So step response. Maybe I need to change this value. Step time. Step timer is this. I can type final values. Let me change this. Maybe just showing a 0, 0. But you have any type of step response here, or what you can do. Basically, I want to show you, depending on your plant, maybe I have to just this one. So in Simulink environment, if you just click on the PID controller, so here we have this options. Okay, so controller type, you can select your parallel form, this one. But what is the best part of the MATLAB, that you have this tuning option, automatic tuning, because it is always very tedious task to get my P, I, and D values depending on my plant. Okay, so but what it will do, you can tune your PID controller. Just click on this tune option, and it will again show you the PID tuner app for you, and using the just drag drop option, and just using your sliding window, you can just follow that whatever your plant is. So again, it will open this PID tuner app within the Simulink environment. Okay. So like this, it is showing you the tune response, and this is your block response. Okay. So what you can do, you can just we have not taken this maybe some example, but what you can do, you can just go for this slider and this one, and what you can do, you can match the things here. Okay, once you are satisfied with this graph match, okay, your reference tracking or this one it's matching for you. What you can do, you can show the parameter values. Okay, so this is your, it will show you the parameter values, like what is your target to achieve your right time, settling time, everything. And if you are satisfied with this one, what you can do, you can just click on update block. So if you just click on the update block, so the value of your P, I, and D will be updated into your this one, into your PID block within the Simulink environment. So using this one, what I can do, I can apply my control theory to designing my system as you are working on. So again, just PID controller is like the part of your Simulink library, and if you want to connect this PID controller to again with your electrical system, so again, how you can connect in between, you can just use the what you will use converter, or Simulink to physical, or this converter you need to use for this one. So for this one, what you can do, you can just apply your control theory to your systems also. Further, I want to discuss, let me, one more library within this one. Okay, so within this, I just told you that we have the Sim Power Systems as a separate toolbox for electrical engineer, which has some special type of library are available for to design your electrical systems. But still this library is available within your Simscape electrical, and we have this specialized power systems library. So if you just visit in this specialized power system library, we have these control, different type of control option, different type of filters, electric machines are available, synchronous and synchronous machines are available. Okay, just passive component. These are the, if you want to design some transmission lines. So RLC, PRLC, parallel RLC branch is available here. Power grid, power electronics. If you want to apply on the power electronics type of application, IGBT. You want to design some type of converter. So we have the so these are the different type of source, utility, and this one. Okay, so let me just show you that what type of application you can also just utilize this library, and it's better that what I can do. What I can do, just let me just open and show you the what are the different type of application examples are there. So if you just open the document of MATLAB and let me just click on the product and let me just show the Simscape electrical. This is my Simscape electrical. Okay, so I have inbuilt examples are given. So within the Simscape electrical or control. So if you just visit here on the examples, let me just click on the examples. So these are the ready-made examples are available. So you can just go through these example like PWM control of DC motor. Okay, this comparison of three-phase port. So you can just open, these are the ready-made and all are the tested examples. We want to work on the converter, buck converter and boost converter. Actually, what are the use of the converter? If you want to convert your one type of support DC boost up converter. So what are you doing? Basically, you are just boosting your voltage for your load. So there are different type of converters are available, amplifier, and if you just go to the specialized power library, so there are 190 examples are given. If you want to start just building your electrical concept, so just start with some examples, that transient analysis of linear circuit, and if you are aware that we can also apply some full wave rectifier, like for example, if I want to start this full wave rectifier. So as you know, so there are two type of configuration for full wave rectifier. Okay, one type of bridge or this is we are using here this two diode only. Okay, center tape. We have just had the center tape approach and full bridge. In full bridge, you generally use the 4 diode. Okay, so in both approach, what you can do, you can just build your full wave rectifier also. So let me just open this example and just we will understand some difference, that how you can this full wave rectifier is built with the help of your specialized library, which is within your this one. So everybody is aware that this is my sine wave, AC voltage source, and this is my transformer. So let me just double click on this one. This is my, I can put the properties of transformer. What are the parameter, winding 2, winding 3. So for this is maybe your step down transformer, okay, or step up transformer. So here we require the low voltage. If your AC is coming, you just apply here transformer to down your voltage. Then you apply here and 2 diodes D1, D2, and using the AC, one time D1 will be on and one time your D2 will be on for positive cycle or negative cycle. Then you are measuring the ID1. This is what is ID1? This is my current measurement and current measurement. And I am just, what is this one? What is this one? What is this? It is not scope. Okay. So basically, what I can do, I can also transfer my signal on the scope. Scope here is separately. This is scope. But what are these 4 blocks are available? Okay. So if you just double click on this block, it is your go-to block. What is this? Go-to block. And what is this near the scope? This is a from block. So what is the use of go to and from block? So if I don't, suppose I want to measure various things in my single circuit. Okay. So if I connect only a single scope here, so I will carry here one signal from scope to this one, one signal from here, one signal from here. So my wire will be complex like this. Okay. So what is the other solution? That I can connect a separate go-to block. So you can find out this go-to block. This is my go-to block in this library. Okay. This is a go-to block and another is from block. Okay. Like you are using the landline phone and mobile phone for communication. So without directly wire connection, what I can do, I can transfer my signal from go to block to from block. But how you can transfer? You need to define a tag name. Suppose I give a tag it as a I1, and so I need to give the same tag name as a I1 here, or V1, V2. So using these go to block and from block, so I want to measure current here. So I have just passed it and I have given the tag name of ID1 because it is the current of diode 1. So meaningful name. It is the second go to block. This is I want to measure the voltage here. I want to just, what I want to do, I want to measure the voltage here also. So now this is my scope. Okay, this is my scope and I want to pass here 4 signal. Like this is VD. So VD, it will transfer VD here. This is my voltage. This is my load voltage. And I want to see the effect of ID1 and ID2 because I am working on the full wave rectifier. So one time I will get the wave from diode 1, diode 2, and I want to display both wave into single window. So I'm just using here multiplexer. So using these go to block and from block, I can transfer my signal without directly wire connection here. Okay. But to solve these type of application, if you are using the component from this library, I require this power GUI. Okay. So I always need to admit this power GUI block. So power GUI block, you can find out the under this specialized power library, and what is this within this power GUI block. Again, it will provide some we can say the simulation types. Okay, so there are 3 types of simulation, like continuous, discrete, or phasor. Okay, so continuous means if you are working on some small system and you want to full output, that we can use this one. And discrete means you can use it for large system, and if you want to just avoid some parts. And phasor system, it can be used for large system, so you will get your output for some specific frequencies. So this is also your full wave rectifier, but what approach you are using here? You are using the specialized power system library. So if you just run it, and you will see the result of this one. So this is your working of full diode like this. Okay, so this is your voltage and voltage drop across your loading, and it is showing the like full wave shapes. So apart from that, these are the fundamental that how you can just use this one to. So there are 3 type of component now you can find out. Okay, so sometimes you can design your system using the specialized power library. Okay, so just remember the things that how you can just utilize this one. And let me just go through the some more example if you want to just. So all example are ready made, and I think you are just maybe if you want to work on some type of special project for power grid or smart grid, or if you want to work on some special type of technology like EV. So let me just show you, let me just share you some resources. Okay, So let me just share you some resources so that you can just understand the things. So first you need to complete the, I will just give you the some on-ramp courses. Okay. So this is the first task for you, but once you have time after your exam or something, what you can do, if you just visit on the MATLAB site, okay, here we have this academia section. And in this academia section, we have this student programs and student tutorial and videos. Okay, or what you can do, you can just student tutorial and videos, and you can just click on student tutorial and videos options. Further, you will find out the various code generation, robotics, and just see this one, physical modeling competition. Let me just open it and let me share this link in the chat box also. So this is the link that you can just subscribe it, or you can type on the Google student competition for physical modeling. So if you want to understand the difference of your Simscape or different type of approaches, whether you are working as a mechanical engineer, and because if you are working on some type of electric EV also, so there may be some mechanical part also available. So there are 12 video lecture series are there, and from here what you can do, you can also download the material. So if you are going to download this material, so with the help of this material and by using the video also, you can just go work on the introduction to vehicle modeling, powertrain. Powertrain is a specialized toolbox within the MATLAB, so that you can just work more fastly on your powertrain systems, multi-body, building component, and if you want to work on some type of battery, so EV or so it has a 12 video lecture series with your material. You can download the material also. So there is some buck boost converter example also available. Ready-made example are available under your electrical. So like this, you can just start to work with smart grid. Further, what are you can do? You can just visit on this solution page, and if you want to just apply more thing, and we have this electrification part. Okay, or if you want to work on some type of special this we have one part here is yeah, in electrification. If you're going to just visit your electrical application, so in which type of application you want to just utilize your domain, like motor drive and transaction motor, renewable energy. If you want to work on renewable energy, so you can just visit on this page, so that you will find out the more resources, EV, full cell electrolyters, microgrid, battery management system. If you want to work, so for example, I want to work and I want to include the AI for electrifications.